chemical bonding and molecular structure. Lewis dot structures are shorthand to represent the valence electrons of an atom. The structures are written as element symbols surrounded by dots that represent the valence electron. Covalent bonds. The bond formed between two atoms by mutual sharing of electrons between them as to complete their octets or duplets. When two atoms share one electron pair, they are said to be joined by a single covalent bond. Example H2. If atoms share two electron pairs of electrons, the covalent bond between them is called double bond. Example O2. If they share three electron pairs, covalent bond between them is called triple bond. Example nitrogen. Octet rule. Kossel and Lewis in 1916 developed an important theory of chemical combination between atoms known as electronic theory of chemical bonding. According to this, atoms can combine either by transfer of valence electrons from one atom to another or by sharing of valence electrons in order to attain their octet. This is known as octet rule. Limitations of octet rule. Incomplete octet of the central atom. In some compounds, the number of electrons surrounding the central atom is less than 8. This is especially the case with elements having less than 4 valence electrons. Example, LiCl, BeCl2, BCl3. Odd electron molecules. In molecules with an odd number of electrons like nitric oxide, NO, and nitrogen dioxide, the octet rule is not satisfied for all the atoms. Expanded octet elements in and beyond the third period of the periodic table have, apart from 3s and 3p orbitals, 3d orbitals also available for bonding. In a number of compounds of these elements, there are more than 8 valence electrons around the central atom. This is termed as expanded octet. Some of examples of such compounds are PF5 and SF6. This theory doesn't account for the shape of molecules. Electrovalent bond or ionic bond. Chemical bond as result of transfer of electron from one atom electropositive to another atom electronegative. Ionic bonds will be formed more easily between elements with comparatively low ionization enthalpies and elements with comparatively high negative value of electron gain enthalpy. Most ionic compounds have cations derived from metallic elements and anions from non-metallic elements. Bond length is defined as the equilibrium distance between the two nuclei of two bonded atoms in a molecule. Bond angle is defined as the angle between the orbital containing bonding electron pairs around the central atom in a molecule or complex ion. It gives some idea regarding the distribution of orbital around the central atom in a molecule, complex ion, and hence it helps us in determining its shape. Bond enthalpy is defined as amount of energy required to break one mole of bonds of a particular type between two atoms in a gaseous state. Unit of bond enthalpy is kg mole minus 1. Bond order is given by the number of bonds between the two atoms in a molecule. Example, bond order of O2 is 2. With increase in bond order, bond enthalpy increases and bond length decreases. Resonance. According to the concept of resonance, whenever a single Lewis structure cannot describe a molecule accurately, a number of structures with similar energy, positions of nuclei bonding and the non-bonding pairs of electrons are taken as the canonical structures of the hybrid, which describes the molecule accurately. Polarity of bonds. In case of heteronuclear molecules like HCl, shared pair of electrons between the two atoms get displaced more towards chlorine. Since the electronegativity of the chlorine is far greater than that of hydrogen, the resultant covalent bond is called a polar covalent bond. Dipole moment. As a result of polarization, the molecule possesses the dipole moment, which can be defined as the product of charge and distance between the centers of positive and negative charge. It is usually designated as Greek letter mu. Mathematically, it's expressed as dipole moment U is equal to charge into distance of separation. VSEPR theory. The shape of a molecule depends upon the number of valence shell electron pairs, bonded or non-bonded, around the central atom. Pairs of electrons in the valence shell repel one another since their electron clouds are negatively charged. These pairs of electrons tend to occupy such positions in space that minimize repulsion and thus maximize distance between them. The valence shell is taken as a sphere with the electron pairs localizing on the spherical surface at maximum distance from one another. A multiple bond is treated as if it is a single electron pair, and the two or three electron pairs of a multiple bond are treated as a single super pair. Where two or more resonance structures can represent a molecule, the VSEPR model is applicable to any such structure. The repulsive interaction of electron pairs decrease in the order. LP-LP is greater than LP-BP and is greater than BP-BP. Geometry of molecules on basis of VSEPR theory. 2BP 0LP linear. Example BeCl2. 3BP 0LP trigonal planar BCl3. 2BP 1LP bent SO2. 4BP 0LP tetrahedral CH4. 3BP 1LP pyramidal NH3 PH3. 2BP 2LP V-shape H2O. 5BP 0LP trigonal bipyramidal PCl5. 4BP 1LP seesaw SF4. 3BP 2LP T-shaped SLF3. 2BP 3LP linear XEF2. 5BP 1LP square pyramidal SLF5 IF5. 4BP 2LP square planar XEF4. 6BP 1LP distorted octahedral XEF6. Hybridization. It can be defined as the process of intermixing of the orbitals of slightly different energies so as to redistribute their energies, resulting in the formations of new set of orbitals of equivalent energies and shape. Salient features of hybridization. Number of hybrid orbitals is equal to the number of atomic orbitals that get hybridized. Hybridized orbitals are always equivalent in energy and shape. Hybrid orbitals are more effective in forming stable bonds than the pure atomic orbitals. These hybrid orbitals are directed in space in some preferred direction to have minimum repulsion between electron pairs and thus a stable arrangement. Types of hybridization: sp. This type of hybridization involves mixing of one s and one p orbital, resulting in formation to equivalent sp hybrid orbitals. Example BeCl2. sp2 hybridization. In this hybridization, there is involvement of one s and two p orbitals in order to form their equivalent sp2 hybridized orbitals. Example BCl3. sp3 hybridization. When there is mixing of one s and three p orbitals of the valence shell to form 4 sp3 hybrid orbitals of equivalent energies and shape. Example CH4 molecular orbital. It gives probability distribution around a group of nuclei in a molecule. They are filled in the same way as atomic orbitals. Molecular orbitals are formed by linear combination of atomic orbitals. Bonding molecular orbital. A molecular orbital that is formed by addition overlap. When the lobes of atomic orbitals overlap with the same sign of two atomic orbitals is known as BMO. It's represented as it favors bonding. Antibonding molecular orbital. A molecular orbital that is obtained by the subtraction overlap with opposite sign of two atomic orbitals is known as antibonding molecular orbital. Represented as it doesn't favor bonding. Bond order. It is defined as the half of the difference between number of electrons in bonding and antibonding orbitals, which is equal to Nb minus Na by 2, where Nb are number of electrons in bonding orbitals and Na are number of electrons in antibonding orbitals. Bond order helps in estimating stability of atom. Sigma molecular orbitals. A molecular orbital which is formed by the overlap of two s atomic orbitals or head-to-head overlap of one s and p atomic orbital or a head-to-head overlap of two p atomic orbitals is known as sigma molecular orbital. Pi molecular orbital. A molecular orbital which is formed by lateral overlap of two parallel p orbitals is known as pi molecular orbital. Sigma 2pz molecular orbital is higher than that of pi 2px and pi 2py molecular orbital in these molecules. Just read it. Okay, send and bye.